What?
All right, so here we are. We're at the high wave exposure transect at Ocean Point. And what I want you to see is we're at the low tide right now. And the lowest zone that you see is that sort of bright green, and it's Chondrus crispus. That's an algae that really doesn't like to be exposed to sun very much. It's normally a much darker red, but it's sun bleached and stressed at this time of year. And it lives subtidally and in the lower tidal height within the tidal zone. So it is going to be, its lower limit, it extends below here. Eventually it will be outcompeted by some corallina algae and some kelp. And it gets pushed up to its physiological limit within the intertidal. And that is right around where you see the Fucus disticus zone forming. Fucus disticus is the organism that it doesn't really provide food for organisms, but it provides cover. It provides canopy for the organisms that live on the actual rocks. And both the Chondrus and the Fucus disticus have very strong holdfasts to withstand the wave energy that they experience in these environments. Moving further up the intertidal, the next zone that we're in is Fucus vesiculosus. Again, we have 3 Fucus species here on the coast. You're going to get to know all of them. Fucus vesiculosus also has strong holdfasts. Again, it is not food for anybody, but it gets pushed higher into the intertidal by Fucus disticus. The next zone up is Fucus spiralis. We're going to be careful walking here. It's a little slippery. Fucus spiralis is the highest Fucus species found on the coast of Maine. It lives just below the barnacle zone. And again, Fucus spiralis gets pushed up into the intertidal by Fucus vesiculosus, and it reaches its upper biological or physiological limit right around here. Historically, we then had the Middleus edulis, the blue mussel, but they've disappeared, and we'll be talking more about that later. We have a few that are hiding in some crevices here, but there used to be a whole zone of them, and they're missing. So the next zone that we have that we're going to be looking at is the barnacle zone. This is Semibalanus balanoides. These are sessile, which means they're anchored to the rock permanently as adults. They do have a planktonic phase, and we can talk about that in the future. But they are brought in, the larval barnacles are brought in on the tide, and they settle in an area where they detect other barnacles, so they know it's a good place to live. The next zone up is this bare rock zone, and this you can see is quite steep here. So this is probably scoured by wave action and debris that's brought in during storms. If we keep moving up in the intertidal at the high energy wave site, we have Calothrix, which is the blue-green algae. And Calothrix is brought in in the waves, and it crashes. And if he looks up the rock a little, this is where the wave comes in and crashes on the rock and splashes high in the intertidal. And so in the high wave exposed sites, we have a high splash zone. And that means that the Calothrix zone is quite extensive here, and it's because of the wave splash. It's the wave energy coming in and splashing higher in the intertidal. So one of the things that's really important for you to see is in a high wave exposed location, we get very distinct zones of the organisms compared to the more protected sites, and we're going to visit those next. So keep in mind, high wave exposure, distinct zones, and they get shifted higher in the intertidal than at the other locations.